I am explaining about chemical properties of metals. Chemical properties of metals, right? Chemical properties of metals. So metals have low ionization potentials and therefore can easily lose electrons from their valence shell. Okay, by losing electrons, metals atoms are changed to cation or positive ions. So metal lose electron easily and therefore they form cation. Metals always lose electrons, they never accept electrons. So they form cation. So okay, and the important thing about this is that they lose electrons from the valence shell, valence. Okay, and suppose they lose one electron, then they'll form okay one plus charge on them. For example, sodium can lose only one electron because only one electron is in the valence shell, therefore okay, sodium loses one electron, so it forms Na plus sign, means it is a cation. This calcium loses two electrons because two electrons are in the valence shell, therefore it forms okay, Ca plus plus. Okay, and aluminum in the same way loses three electrons because aluminum has three electrons in the valence shell and therefore it forms okay Al plus plus plus, three plus charges, right? So metals forms cation, right? Sodium metals which are very highly reactive, okay, sodium metal, potassium metal are very highly reactive, therefore they are highly electropositive. Electropositivity is determined by the ease the metal lose its electron from the valence shell. Okay, now in the same way, alkaline earth metal like it is calcium, strontium, barium. Okay, so they are earth alkaline metals. Therefore, they forms okay cation having a plus two charges, plus two charges. Aluminum, zinc, iron they forms okay they are less electropositive because they are not able to lose the electron from the outermost shell easily here now. Okay, so the question is about formation of cation. So cation is formed by losing electrons and this usually is done by the metals. Metals always lose electrons, therefore they form cation. Now, reactivity of metals. Yes, metals are not equally reactive. Equally reactive means they are not able to lose electrons very easily. Reactivity of metal is also connected to okay the formation of positive ion easily. So this sodium, potassium, so they are very reactive here because they can lose the electrons from the outermost shell easily. Therefore they are okay very reactive metal. Okay, some metals are not as reactive as sodium, potassium because they don't lose the electrons easily. Now, uh, the reaction of metals with water is usually exothermic reaction. When sodium reacts with hydrogen, it forms sodium hydroxide and hydrogen gas is produced. So the reaction is highly exothermic. So hydrogen catches fire as soon as it is produced. So metals like iron, gold, silver, etc. are not very reactive. They are not very reactive. They do not react even with steam. Okay, which metals? The metals like iron, gold, silver. They are not so reactive here. They don't react even with steam. In fact, silver, gold, but platinum, etc. are called noble metals because they do not react with any chemical reagent of normal temperature and pressure. They are therefore said to be least reactive metals. So, on the basis of figures of reactions uh, with various chemical reagents such as water, oxygen, it's okay, and acids as well as a displacement reaction, the metals have been arranged in a series in the decreasing order of their reactivity. This arrangement of metals in a series in the decreasing order of their activity is called activity series of metals. Yes, metals have been arranged according to their activity series here. Um, uh, they have been arranged into a series and according to their activity, and that's known as the activity series. So the first metal which is very reactive is the potassium. Okay, potassium, the very reactive here. Then comes the sodium, then comes calcium, magnesium, aluminum, zinc, iron, lead, hydrogen. Okay, hydrogen is not a metal. Then why this hydrogen has been put in between the series of reactivity of metal? I will tell you later on. Then after hydrogen is copper, mercury, silver, gold, etc. It's okay. So reactivity decreases from top to bottom. Now, why is this hydrogen in the series of metal? So the hydrogen is the series in the metal is because the metals above hydrogen like sodium, potassium, calcium, magnesium, aluminum, zinc, iron, and lead, they can okay they can displace hydrogen from acid, and therefore this hydrogen is being given here now, and the metals below hydrogen cannot displace hydrogen from the acid, so they are copper, mercury, silver, gold, etc. So therefore hydrogen is kept there, right? This is the only reason. Now, and next it is okay reaction with oxygen. Reaction with oxygen, they produce oxide, and this oxide is the basic oxide. Metals form basic oxide. Sodium reacts with oxygen to form sodium oxide, and that is a basic oxide. Okay, because this is basic in nature, it has a property when this sodium oxide is dissolved in water, is formed sodium hydroxide, and that is why it is called basic oxide. The same way magnesium and this oxygen forms magnesium oxide. Aluminium and oxygen form aluminium oxide. So zinc and this oxygen form zinc oxide. Okay, iron with oxygen forms this ferric oxide. Copper forms copper oxide, like this it is here. So they forms oxides of metals, and these metals are these oxides. So that's when the metals are basic in character because they have the property of base. When they are dissolved in water, they form base. Right? Okay. Now one thing here now, what is amphoteric oxides? Amphoteric oxides. So those metal oxides which show both acidic as well as basic behavior. Both acidic and basic behavior are known as amphoteric oxide, and examples are zinc oxide and aluminum oxide. Yeah. Now, reaction of metals with water. Metals react with water forming metal oxide or hydroxide and hydrogen gas evolved. So all metals do not react with water with the same intensity. So some metals decompose water at room temperature while others decompose hot water and steam. Okay, alkali metals like sodium, potassium decompose water easily at very low temperature, giving off hydrogen. So the examples you can say like sodium plus water. So that is called sodium hydroxide and hydrogen gas is produced. In the same way, magnesium does not react with cold water. Magnesium does not react with cold water, it reacts with hot water to form magnesium hydroxide or hydrogen. Right? So this magnesium reacts with water to form magnesium hydroxide and oxygen. So okay, the reaction of calcium is uh, less violent with water. So calcium plus water is calcium hydroxide, and this hydrogen gas is evolved. Aluminium does not react with either cold or hot water. It reacts with steam to form a metal oxide and hydrogen. Okay, so aluminium does not react with cold or hot water. They react with steam to form hydrogen. So aluminium plus water, so that gives aluminium dioxide plus hydrogen. Okay, in the same way, zinc also reacts with hydrogen to form reacts with water to form hydrogen and zinc oxide, right? Reaction of metal with dilute acids. Metal react with dilute acids such as hydrochloric acid and sulfuric acid to give hydrogen and salt. Okay, this magnesium also rapidly reacts with dilute acid, but the reaction is not violent. Okay, this magnesium plus HCl, so that gives magnesium chloride plus hydrogen. But the reaction of sodium in water with acid it is very violent reaction. Okay, it is very violent reaction. Okay, but reaction of sodium or of this what magnesium with water is not so much violent. So this means that sodium is more reactive than magnesium. This shows, yeah. So aluminium also reacts with dilute acids to form carbonic salt and evolving hydrogen. So aluminium plus 6HCl. So that gives aluminum chloride and hydrogen. Yeah. Copper remains unaffected by dilute hydrochloric acid or sulfuric acid. Okay, this indicates that copper is least reactive towards dilute acids. Yeah, and inspection of the activity series would reveal that metals occupying higher position than hydrogen displaces hydrogen from the dilute acid. Higher position of the metals, metal greater is the Eg with which metals displace hydrogen from the dilute acid. The sodium displaces hydrogen from the dilute acid and much more early than magnesium. So metals like copper, silver, gold, etc. are placed below hydrogen in the activity series. Okay, therefore they cannot displace hydrogen from the acids. So this reactivity series is very important series now. So this hydrogen, the metals above hydrogen, they can displace hydrogen from this acid, but the metals below hydrogen, they cannot displace hydrogen from the acids. So that is why in this electrochemical series, or you can say the reactivity series of metals, hydrogen has been taken as the standard uh, as to which metal is more okay, more strong, or the less strong it is, right? So today this much, then in the next video I'll tell you something else. Okay, thank you, watch it and enjoy it.